Johannes Kepler was a German mathematician and astronomer who is best known for his three laws of planetary motion, which describe the movement of planets around the Sun. Kepler was born in 27 December 1571 in Walterstadt, which is near present-day Stuttgart in modern Germany. Since his childhood, Kepler has been interested in mathematics and astronomy. He went to University of Tübingen, where he learned about the Copernican model of planetary motions, in which Sun is at the center and all the other planets orbit the Sun. He became a fan of Copernicus and he began studying planetary motions. In his early days, he wanted to become a minister. However, people suggested him to teach astronomy and mathematics, so he took a job of teaching mathematics in Graz, Austria. As he was interested in astronomy, to help him with his research, he began correspondence with different famous astronomers of that time. Tycho Brahe was one of them. When he heard about Brahe's work and wrote to him expressing his admiration for his astronomical observations, Brahe was impressed with Kepler's knowledge of mathematics. However, he was unhappy that Kepler was using Copernicus's data, which were erroneous. However, they began regular correspondence. In 1600, when religious tension grew in Graz, Kepler's position was threatened, so he moved to Prague. At that time, Tycho was building an observatory in the castle of Benetsky. So Tycho invited him, and on 4th February 1600, Kepler met Tycho and his colleagues. Initially, Kepler was their guest. Kepler started working there. However, after an argument regarding a formal arrangement of employments, Kepler left Tycho and went to Prague. After a couple of months, Tycho gave him a formal position, so Kepler came back to the castle of Benetsky. Kepler's job was to help Brahe with his astronomical observations, which he did with great skill. In 1601, Tycho unexpectedly passed away and Kepler took his position. He became the imperial mathematician in the castle of the Benetsky. When he was working with Tycho, he gave him the problem of solving the orbital parameter of the planet Mars. Initially, Kepler thought that it will take him a couple of months. However, it took much longer, in fact several years. The main problem was that all the observations were made from Earth. However, as Earth is also orbiting Sun, without knowing the exact orbit of Earth, it was almost impossible to know the orbit of Mars. Here comes the brilliance of Kepler. Kepler finds out that Mars comes exactly the same position in its orbit every 687 days, which is actually the orbital period of Mars. Therefore, if we can make observations of Earth from Mars in a gap of 687 days, then we can get information about the orbit of Earth. Once we know the orbit of Earth, we can calculate the orbit of Mars. Brahe had made extensive observations of Mars, and Kepler was able to use these observations to find the orbit of Mars. Kepler also studied the orbit of other planets and derived three laws of planetary motions. The first two laws were given in 1609 and the third law appeared 9 years later in 1618. These laws are empirical. That means these laws are not based on any deeper theory, but accurately describe the orbital motion of the planets. The first law of planetary motion, also known as the law of orbits, states that the planets orbit the Sun in elliptical paths and Sun is in one of the focus of the ellipse. This was significant departure from the prevailing view of the universe at that time, which held that planets move in perfect circles. Kepler's discovery of the elliptical orbits of the planets was a crucial breakthrough in our understanding of the movements of celestial bodies. The second law of planetary motion also known as the law of equal areas, states that the line drawn from a planet to sun will sweep equal areas in equal interval of time. In other words, when planet is closer to the sun, it moves faster, and when it is farther away, it moves slower. The law helped to explain why planets moved at different speeds as they orbit the sun. It is worth pointing out the fundamental physics that lies behind this second law. Planets possess potential and kinetic energy. The potential energy relates its distance to the sun, reducing as it nears the sun. The kinetic energy relates its speed. As the planet is moving in the space, there is no mechanism for it to lose energy, so the sum of the potential and the kinetic energy must remain constant. In an elliptical orbit, the planet varies its distance from the sun, so for its total energy to be conserved, when the potential energy reduces as it nears the sun, and its kinetic energy must increase. It must thus move faster in its orbit, exactly as implied by the second law. The third law relates the period of the planet's orbit T with A, the semi-major axis of its orbit, and states that the square of the planet's orbit T is proportional to the cube of the semi-major axis of its orbit A. A highly significant result of this third law is that it enables astronomers to make a very accurate map of our solar system. The relative position of the planets could be plotted precisely, but the map has no scale. A way to solve this problem would be to make an accurate measurement of Earth to Sun distance, which is the topic of our next video. Once this distance was measured, it gave the full map of our solar system. Kepler's works were groundbreaking, and they laid the foundation of the modern astronomy. His laws of planetary motion provided a more accurate description of the movements of planets than any previous theory had done. Kepler's work also challenged the prevailing view of our universe at that time, which held that planets and stars moved in a perfect circles. It makes him one of the greatest astronomers of all the time. So thank you for watching this video. We hope that you found this information informative and helpful. If you have any questions or comments, please feel free to leave them down below. Don't forget to like and subscribe to our channel for more videos like this, and also don't hesitate to share this video with your friends and family who might find it interesting. Thanks for tuning in, and we'll see you in the next video.